Before we move on to more complex programming, we need to learn about programming subroutines in Arduino, which is actually programming in the C language. Now, subroutines in C are called functions, and we've already used them, but not as subroutines. If you'll recall, our bare minimum sketch must have a minimum of 2 functions, setup and loop. And just like subroutines in other programming languages, the functions will run in sequence, or we can call a function from anywhere within the program. In fact, in the next lesson, we'll call functions from a completely other program. So let's make a function first. It needs a return type. That was that word void I mentioned when we first started Arduino. And then the name of the function, this is the name you will use to call this subroutine. So it can't have any spaces, it must be composed of letters, numbers, or the underscore, and it cannot have a number as the first character. It is also case sensitive. Obviously, the word can't be an instruction or some pre-designated word like hi. The same issues you have naming variables. We'll slap on 2 brackets. We'll come back to this in a second. And finally, everything within the function itself is closed between 2 braces. Notice there is no semicolon after the function declaration. So I'm going to rebuild my Dance Dance Party sketch using functions. Now, my original sketch was really long because of all the steps in the dance were in a series of instructions. Now we'll divide up my dance moves into separate functions and then call those functions from within the loop function. Now my first dance move is simply stepping ahead. So I call my function by that name, step ahead. I'll copy that move. Complete with my previous timing into the function. I'll make a second function called step back, and copy the move for that from my Dance Dance Party. From my Dance Dance Party sketch into that function. So I now have 2 functions upon which to call. I'm going to copy and paste the setup from the original Dance Dance Party sketch. And now we're set up and ready to go. So in the loop function, I'm now going to call my subroutines, my functions, as I need them. I'm going to start my dance routine by making 4 forward and back movements. Now to call a function, I simply type in the name of the function. Two brackets, which still contain nothing. We'll come back to this in a second. And a semicolon. So I call the step ahead and then step back functions. And then I do that 3 more times. All the robot will do is move forward and back, hopefully in time with the music. I'm going to throw in a 1-second delay here, just so we can see the end of the moves before it loops back to the beginning again. Remember, this loop function continually loops. So because I have all the functions after the loop function, the program will never go past the end of the loop function. It will be infinitely looping back to the beginning of the loop function. When I flash the robot with this sketch, the robot will start its sequence of 4 forward-backward movements, pause a second, and then perform the movements again. It is calling these movements by subroutines, functions. If I add some more functions, like the do-si-do, which was just spin around on the spot, or shuffle back left, or right, I can build a complex dance sequence simply by calling all of the functions in sequence of movement from the loop function. It makes it real easy to change the dance routine and saves a lot of code, because previously, every time I wanted to make a move forward, I'd need to put in all of these lines of code. I just replaced pages of code with a couple of calls and one copy of each move in a function. Now I could set up some global variables as well for the timing delays. And then I can change the timing of the entire dance sequence by changing a couple of global variables, or even one global variable of the beat time in the music. Have the subroutines perform some math to calculate the delays it needs to make either during movement or the pauses in between movements based on the beat time. I can then have it more accurately dance to the timing of different music by simply changing one global variable at the beginning of the sketch. Now, none of these functions sent or returned any information. And so all of the functions and function calls had these empty brackets. But we can both send information to a function and get information back when the function returns. That's what we use these brackets for. Let's first send some information to a function. We'll make a void function, so we will send information to the function, but the function won't send anything back. So you make the function just like before, only you put the names of the variables inside the brackets. Separate them with commas and spaces if there's more than one. For example, in just a few short lessons, we're going to learn how to use our TFT screen, TFT LCD screen. So you actually paint each individual pixel on the screen by providing an X and a Y coordinate for the specific pixel that you want to paint, and then the color that you want to paint that pixel. It's a series of instructions to send that color over the communications bus. So we'll write a function to perform this duty. We'll call our function void paint pixel, and in the brackets we'll put the variables X, Y, and color, spaced and comma separated. And you have to declare the type of variable, whether it's an integer or some other kind. We'll get into that in more detail in the math and microprocessors lesson. So now I put all of my instructions inside the braces as to what to do with these variables. Now I hope you get the gist of what I'm saying here, because the instructions to paint on the TFT screen are quite complicated to understand, so I don't want to confuse you. So just imagine that in between the braces there's a series of instructions here, okay? Putting the X address on bus, strobe the right line, put Y address on bus, strobe right line, put color value on bus, strobe right line. So, now that I've got the function set up, I simply call that function from somewhere else, like the loop function. And when I call it, I provide the values for the three variables in order and separated by commas. So the variables within the brackets are called arguments. So this call will tell the function to paint the 8th pixel from the left side on the x-axis, the 4th pixel down from the top on the y-axis, and we'll paint that pixel with the color AE, whatever color that is. So we send the data to the function when we called it. But when the function finishes its task, it just returns from whence it came and brings nothing back with it. The sketch continues on right there, right where it left off. So now let's say we want to send information back from the function. The function performs some calculation and sends the result back when it returns. When you build the function, it is no longer a void function because it is returning something. You need to specify what it's returning. Is it bringing back an integer, a floating point number? So let's just return an integer just to keep it simple. So we start off with the int, then the function name, and if you have any arguments, they are put in the brackets like normal. Now, to keep it simple, I'm not going to use any arguments. We are not sending any data to the function. We then have the function itself in between the braces. Now, in this case, I'm going to use an analog read and then perform some math on it. So let's say A0 is connected to a thermistor to read the temperature. Now, because the analog read simply returns a number representing the voltage on pin in the A0 pin, we have to convert that voltage into a temperature. So by calibrating the analog reads, I figured out that to convert the analog number I read into degrees Celsius, I had to use this formula. Now, because I can run my Arduino on either 5 volts or 3.3 volts, I provide the supply voltage declaration elsewhere in the sketch. So here is where I call the subroutine. It's very inconspicuous, but there it is. I just told it to call the temp calculator subroutine. It jumps down to the function, and my function will perform the calculation and return from whence it came with the value that I calculated. In this case, I make the variable ctemp. So when I call the function performs the calculation, but notice that the sketch doesn't recognize the variable itself, only its value. I've assigned a different variable name, temperature. Now, I did this deliberately so you could see how the sketch handles the variables that it passes between the functions. I basically told it, call the temp calculator function, and whatever number that gives you, put that into the temperature variable. So it did. even though the variable itself was called ctemp in the function. Just to, confuse things. Yeah. So just remember, computers only deal in numbers. It doesn't care about the variable name. It cares about what the number is that is contained within that variable. And that number is what gets passed on to the variable that I assigned, which was temperature. It then sends a serial print to the serial monitor, printing the words the current temperature is, and then the calculated temperature. Notice I used the temperature variable for the serial print. If I had used ctemp in there, I would get an error because I did not declare the ctemp variable within the loop scope. It was declared within the temp calculator scope. So as we move on, we're going to dive into libraries and we're going to use these functions a lot. In the meantime, why don't you build up a dance sketch to practice writing and using functions like I did here. Only make a series of dance moves with each move where each move has its own function, then simply call the functions one at a time to build up your dance routine. See for yourself how much work and how much code this saves you.